Welcome back to the course Introduction to Green Process Engineering. The focus of today's video will be solvents. Solvents are chemicals that are used nearly everywhere, and at present they are mostly made from fossil resources. But are there renewable solvents available that can substitute fossil-based ones? The processing of goods requires chemicals. In this graphic, you can see the industrial ecosystems that require solvents. And what you should take from this picture is that nearly every industrial ecosystem requires solvents. If you want to see more details on the different industrial ecosystems, you can follow the link in the additional information. So, which solvent classes are we talking about? And what are applications or uses in general for these solvents? When talking about solvents, we generally distinguish between hydrocarbon and oxygenated solvents. Hydrocarbons summarize aliphatic and aromatic hydrocarbons and paraffins. But let us have a closer look at solvent classes. The main solvent classes we are talking about are alcohols, and they are used, for example, in perfumes. Ketones, which are used as other substances, but also as pesticide. Esters is a class of solvents that you have smelled if you've ever used a glue. Here, ethyl acetate is often used as the solvent. But esters are also very much connected with pharmaceuticals. Also, ethers are used on a daily basis in cleaning agents, and hydrocarbons are used, for example, as lubricants. Aromatic hydrocarbons are used as paints, lacquers, inks, adhesives, rubber, and cleaning agents. By far the largest proportion of solvents is used in paintings and coatings. Due to the REACH regulation, which in long means registration, evaluation, authorization, and restriction of chemicals, halogenated solvents are not named here, as they are anyhow prohibited in the European Union. As already said, the solvents are mainly produced from fossil resources. But do we have solvents from renewable resources? Yes, we do have solvents from renewable resources, and I will show you two examples of such solvents and also connect them with potential uses or areas where they are used already. First, we will discuss gamma-valerolactone, short GVL. GVL is known to be an excellent solvent, and due to its polarity, it is fully miscible with water. Here you see the production pathway from renewable resources. Two ways are possible. The first schematic shows the production from biomass, where C5 and C6 sugars, mainly cellulose and xylene, are reduced to levulinic acid, which further is catalytically converted to GVL. The second route uses fructose, that is acid catalyzed and converted to levulinic acid and formic acid. With a supported metal catalyst, they are converted to GVL, water, and CO2. This route being a one-pot synthesis route. Due to its structure and properties, GVL can be classified as a highly dipolar aprotic solvent and is also able to replace solvents with similar properties. Such solvents are N-methyl-2-paralidone, dimethylpropylenurea, dimethylacetamide, dimethylformamide, dimethyl sulfoxide, and most prominently, acetone. You have probably already heard of ionic liquids, and dipiodectic solvents can be classified as a specific class of ionic liquids. Dipiodectic solvents are made up of two or more compounds that are solid at room temperature, but when mixed together, they form a liquid phase. Both hydrophilic and hydrophobic dipiodectic solvents are developed, and it is clear that the applications for these two are different. Some substances dipiodectic solvents can be made of are betaine, which is extracted from sugar molasses, or glycerol, which is a side product of biodiesel production, to name just two. What can deep eutectic solvents be used for? These solvents are very prominently named in the roadmap of the pulp and paper industry. Here, they can be used for lignin dissolution at lower temperature, but they are also used in metal processing, chemical synthesis, and sustainable energy solutions, for example, in electrochemical energy storages. What you should take from this lecture is that we do have alternatives to fossil-based solvents. However, we are only at the beginning of material transformation in this area. In conclusion, today we had a look at solvents derived from renewable resources. As example, gamma-valerolactone and deep eutectic solvents were named. After watching this video, you should be aware that material transformation, just like energy transformation, is an ongoing process, and that we do already have alternative solvents available in some cases. I hope you enjoyed this video, and I hope you also take the chance to watch the other videos of this course.